Hi, good day. Welcome to Network Troubleshooting. Who is the best network administrator or systems administrator that you have ever seen? Why do you think this person is so good at it? Likely, it is because this person is really good at troubleshooting network problems. They are probably experienced administrators, but that is not the whole story. Good network troubleshooters generally go about this in a methodical fashion, and they use all the tools available to them. The truth is that the only way to become a good network troubleshooter is to be always in troubleshooting. It takes time to be good at this, but luckily for you, there are many tips and tools that you can use. This module covers the different methods for network troubleshooting and all of the tips and tools you need to get started. So this video lecture is divided into two parts. The Network Troubleshooting Part 1, which covers network documentation, troubleshooting process, and troubleshooting tools. Part 2 covers symptoms and causes of network problems and troubleshooting IP connectivity. Alright, so for the module objectives, so you should be able to troubleshoot the enterprise networks. So topic or subtopics includes network documentation, troubleshooting process, troubleshooting tools, symptoms and causes of network problems, and troubleshooting IP connectivity. Okay, so let's start with documentation or network documentation. As with any complex activity like network troubleshooting, you will need to start with good documentation. Accurate and complete network documentation is required to effectively monitor and troubleshoot networks. So common network documentation includes the following. You've got physical and logical network topology diagrams, network device documentations that record all pertinent device information, and network performance baseline documentation. So all network documentation should be kept in a single location, either as a hard copy or on the network on a protected server. So backup documentation should be maintained and kept in a separate location. Network topology diagrams keep track of the location, function, and status of devices on the network. So there are two types of network topology diagrams, namely, you've got the physical topology and the logical topology. So physical topology shows the physical layout of the devices connected to the network. You need to know how devices are physically connected to troubleshoot physical layer problems. Information recorded on the physical topology typically includes device name, device location, including the address, room number, rack locations. Also included is the interface and port used, cable type, and the figure here shows a physical network topology diagram. So the next one is a logical topology. So it could be an IPv4 logical topology or an IPv6 logical topology. So a logical topology or logical network topology illustrates how devices are logically connected to the network. This refers to how devices transfer data across network when communicating with other devices. So symbols are used to represent network components such as routers. You've got servers, switches, hosts, and so on. So additionally, connections between multiple sites may be shown, but do not represent the actual physical location. So information recorded on a logical network topology may include the following: device identifiers, IP addresses and prefix lengths, interface identifiers, routing protocols, so static routes, layer 2 information like VLANs, trunks, user channels. Now the figure here displays a simple logical IPv4 topology. Now you also have the logical IPv6 topology. So although IPv6 address could also be displayed in the same as IPv4 logical topology, for the sake of clarity, we have created a separate logical IPv6 network topology on this presentation. Okay? Next, so let's talk about the network device documentation. Network device documentation should contain accurate, up-to-date records of the network hardware and software. It's sort of an inventory. So documentation should include all pertinent information about the network devices. So many organizations create documents with tables or spreadsheets to capture relevant device information. So we have a router device documentation. Okay, so the table displays the sample network device documentation for 2 interconnecting routers here. Okay, so this includes the device, right? The model, okay, the description, okay, so the location, the iOS version, and the license. Also included are the connections on each of the interface, including the IP address, okay, MAC address, and the routing protocols used. Okay, so next is you'll have the LAN switch device documentation. So this table displays sample device documentation for switch LAN. So similar with that of the router. All right. So this includes port description. Okay, so you've got the access, VLAN. Okay, so the trunk, if it is a trunk. Okay, user channel, a native VLAN, and if it is enabled or not. Okay, so yes or shut down. Okay, and the last one is the end system documentation. Okay, so the end system documentation files focuses on the hardware and software used in servers, network management consoles, and other workstations. An incorrectly configured end systems can have a negative impact on the overall performance of a network. For this reason, having access to end systems device documentation can be very useful when troubleshooting. So this table here displays a sample information that could be recorded in an end system document. Okay, next. Okay, so establishing a network baseline. So the purpose of network monitoring is to watch network performance in comparison to a predetermined baseline. So a baseline is used to establish a normal network or system performance to determine the personality of a network under normal conditions. So establishing a network performance baseline requires collecting performance data from the ports and devices that are essential to network operations. So a network baseline should answer the following questions. Okay. So how does the network perform during the normal or average day? What are the most errors occurring? So you could have asked that. Okay. So what part of the network is most heavily used? Or what part of the network is least used? So which devices should be monitored and what alert threshold should be set? Next is, can the network meet the identified policies? Okay, so measuring the initial performance and availability of a critical network devices and links allows a network administrator or systems administrator to determine the difference between abnormal behavior and proper network performance as the network grows or traffic patterns change. The baseline also provides insight into whether the current network design can meet business requirements. Without a baseline, no standard exists to measure the optimum nature of network traffic and congestion levels. Okay, so analysis after an initial baseline also tends to reveal hidden problems. The collected data shows the true nature of congestion or potential congestion in the network. It may also reveal areas in the network that are underutilized and quite often can lead to network redesign efforts based on the quality and capacity observations. So the initial network performance baseline sets the stage for measuring the effects of network changes and subsequent troubleshooting efforts. Therefore, it is important to plan for it carefully. All right. Okay. So, what are the steps in network documentation? Okay. So, step number one is determine what types of data to collect. Okay. So, when conducting the initial baseline, start by selecting a few variables that represent the defined policies. If too many data points are selected, the amount of data can be overwhelming, making analysis of the collected data difficult. So start out simply and fine-tune along the way. Some good starting variables are interface utilization and CPU utilization. Okay. Step number two is identify devices and ports of interests. So use the network topology to identify those devices and ports for which performance data should be measured. Devices and ports of interest includes the following. So you've got the network device ports, okay, so that are connected to the network devices, servers, all right. What else? Key users, anything else considered critical to operations. Okay. So a logical network topology can be useful in identifying key devices and ports to monitor. So in the figure here, the network administrator has highlighted devices and ports of interests to monitor during the baseline tests. Okay. So the devices of interest includes, okay, so PC1, this is the admin terminal. The two servers, for example, server 1 and server 2. All right. We've got server 1 here, server 2 there. Okay. The ports of interest typically includes router interfaces and key ports on the switches. So all of this dot or with dotted orange there. So it could be the point of interest for the administrator. Okay. So by shortening the list of ports that are pulled, the results are concise. So the network management load is minimized. So remember that an interface on a router or switch can be a virtual interface, such as SVI or the switched virtual interface. Step number 3 is determine the baseline duration. So the length of time and the baseline information being gathered must be long enough to determine a normal picture of the network. So it is important that daily trends of network traffic are monitored. Okay, so it is also important to monitor for trends that occur over a longer period, such as weekly or monthly. Okay, so for this reason, when capturing data for analysis, the period specified should be at a minimum 7 days long. All right, so 7 days long, last no more than 6 weeks unless specific long-term trends needs to be measured, and generally 2 to 4 week baseline is adequate. Okay, and then also you have to conduct an annual analysis of the entire network. Analysis must be conducted regularly to understand how the network is affected by the growth and other changes. Okay, so that's determining the network baseline and also the duration of the baseline. Okay, so let's talk about data measurement. So when documenting the network, it is necessary to gather information directly from the routers and switches. Obvious useful network documentation commands include ping, traceroute, and telnet, as well as all the show commands on the routers and switches. Okay, so the table here lists some of the most common Cisco IOS commands used for data collection. Okay, so manual data collection using show commands on individual network devices is extremely time-consuming and is not a scalable solution. So manual collection of data should be reserved for smaller networks or limited to mission-critical network devices. So for simpler network designs, baseline tasks typically use a combination of manual data collection and simple network protocol inspectors. Okay, so sophisticated network management software is typically used to baseline large and complex networks. So these software packages enables administrators to automatically create review ports or reports. Okay, compare current performance with historical observations, automatically identify performance problems, and create alerts for applications that do not provide expected levels of service. So establishing an initial baseline or conducting a performance monitoring analysis may require many hours or days to accurately reflect network performance. So network management software or protocol inspectors and sniffers often run continuously over the course of the data collection process. So again, you could have, well, the useful commands for me in troubleshooting are ping, okay, trace routes, but these commands here can help you simplify and solve network problems. Okay. All right, let's move on to the network troubleshooting process. So general troubleshooting procedures. So troubleshooting can be time consuming because networks differ, problems differ, and troubleshooting experience varies. However, experienced administrators know that using a structured troubleshooting method will shorten the overall troubleshooting time. Okay, so therefore, the troubleshooting process should be guided by structured methods like what is presented here. This requires a well-defined and documented troubleshooting procedures to minimize wasted time associated with erratic hit and miss troubleshooting. So, however, these methods are not static. So the troubleshooting steps taken to solve a problem are not always the same or executed in the exact same order. So there are several troubleshooting processes that can be used to solve problems. So the figure displays the logic flowchart of a simplified three-stage troubleshooting process. So however, a more detailed process may be more helpful to solve a network problem. So basically, network troubleshooting starts with gathering the symptoms. Okay, so you should know what are the symptoms of the problem. Stage number 2 is you need to isolate the problem. Okay, and isolating the problem comes in also is isolating the components. So you have to identify the components that is directly related to the problem and isolate components that are not part of the problem. So after identifying the problem, so the next step, stage 3, is to implement corrective action. Okay, so implementing the corrective action, okay, so the problem could be fixed or not. So if you were able to apply your corrective action and it fixed the problem, then you need to document the solution and save the changes. So the end result of any troubleshooting is to document the solution. Okay, so document how you fix the problem. Okay, but sometimes after applying corrective action, okay, so you will not be able to fix a problem. Okay, and if it did not fix a problem or it created another problem, you have to undo the correction and start again. Okay, so not all corrective action can solve the problem. So sometimes it leads to creation of another problem. So you should be able to have a fallback, okay, or to remove the corrective action, okay, and go back to gathering the symptoms. So it is basically a cycle. Okay. All right. So next is the 7-step troubleshooting process or procedures. Okay. So you've got defining the problem, gather information, analyze information, eliminate possible causes, propose hypothesis, test hypothesis, and solve the problem and document the solution. Okay, so let us discuss this in detail on the next section. So the figure displays a more detailed 7-step troubleshooting process. Notice how some steps interconnect. So this is because some technicians may be able to jump between steps based on their level of experience. So let us start with defining the problem. Okay, so the goal of this stage is to verify that there is a problem and then properly define what the problem is. Problems are usually identified by symptoms. Okay, so example, network is slow and has stopped working. Okay, so network symptoms may appear in many different forms, including alerts from the network management systems, console messages, and other complaints. Okay, or complaints coming from the end users. So, while gathering the symptoms, it is important to ask questions and investigate the issue in order to localize the problem to a smaller range of possibilities. So, for example, is the problem restricted to a single device, or maybe a group of devices, or the entire subnet, or the network of devices? Okay, so that is localizing the troubleshooting. So in an organization, problems are typically assigned to network technicians as trouble tickets. Okay, so these tickets are created using a trouble ticketing software that tracks the progress of each ticket. Just like reporting your problem with your ISP. If you have experienced problem with your ISP or with your internet connectivity at home, you are calling the call center, right? You are calling the support. And your problem is assigned to the technician via ticketing system. Okay, so trouble ticketing software may also include a self-service user portal to submit tickets. So access to a searchable trouble tickets, knowledge base, remote control capabilities to solve end user issues, and more. Okay. All right. So next is you need to gather the symptoms or gather the information. So in this step, targets, example, host devices to be investigated must be identified. Access to target devices must be obtained and information gathered. So during this step, the technician may gather the document, okay, and also it may gather also document more symptoms depending on the characteristics that are identified. So if the problem is outside the boundary of the organization's control, example, lost internet connectivity outside of the autonomous system, contact an administrator for the external system before gathering additional network symptoms. Okay, so to sum up, well, gathering information is you should have identified the target. Okay, accessed and information gathered. Okay, so the third one is analyze information. Possible causes must be identified. The gathered information is interpreted and analyzed using network documentation. So network baselines, searching organizational knowledge bases, searching the internet, and talking with other technicians is a technique on analyzing information. Okay. Next is eliminate possible causes. So if multiple causes are identified, then the list must be reduced by progressively eliminating possible causes to eventually identify the most probable cause. So troubleshooting experience is extremely valuable to quickly eliminate causes and identify the most probable cause. Okay? Next, you have to propose the hypothesis. So when the most probable cause has been identified, a solution must be formulated. So at this stage, troubleshooting experience is valuable when proposing a plan. Okay? So next is you need to test the hypothesis. So before testing the solution, it is important to assess the impact and urgency of the problem. For instance, it could be a solution, okay? It must have an adverse effect on other systems or processes. So the severity of the problem should be weighted, okay, and weighed against the impact of the solution. For example, if a critical server or router must be offline for a significant amount of time, it may be better to wait until the end of the operations, okay, or the end of the workday to implement the fix. So sometimes a workaround can be created until the actual problem is resolved. So create a rollback plan identifying how to quickly reverse a solution. This may prove to be necessary if the solution fails. So next is you need to implement the solution and verify that it has solved the problem. So sometimes a solution introduces an unexpected problem. Okay, so therefore, it is important the solution be thoroughly verified before proceeding to the next step. So if the solution fails, the attempted solution is documented and the changes are removed. Okay, so the technician must now go back to the gathering information, okay, step and isolate the issue. All right, so what we're talking about is in here. So if you apply the corrective actions, all right, and it does not solve the problem, so you need to remove the actions you imposed, okay, and then you go back to the cycle. All right. Okay, so the last one is solve the problem. Okay, so you were able to solve the problem. So when the problem is solved, inform the users and anyone involved in the troubleshooting process that the problem has been resolved. Just like personnel from your ISP, right? So if they fix the problem, they informed you, and also they enlightened you of what the problem is, okay, and how they fix the problem. And of course, eventually, after informing the end users that the problem is fixed, they have to call their support, okay, and report also that the problem has been fixed. Okay, so that's how it works, right? So other IT team members should be informed of the solution. Okay, appropriate documentation of the cause and the fix will assist other support technicians in preventing and solving similar problems in the future. So that's how troubleshooting should be performed and done. All right, everything should be documented. Okay, so next is question the end user. So we are doing some sort of a triage. All right, so we are investigating and questioning the end users. So many network problems are initially reported by an end user. However, the information provided is often vague or misleading. For example, users often report problems such as the network is down, I cannot access my email, or my computer is slow. Okay? So in most cases, additional information is required to fully understand the problem. This usually includes or involves interacting with the affected users to discover the who, what, and when the problem exists or arises. So the following recommendations should be employed when communicating with a user. Okay, so the guidelines, right? So speak at the technical level they can understand and avoid using complex terminologies. All right, so always be considerate and empathize with a user while letting them you will know, okay, you will help them solve their problem. Users reporting a problem may be under stress and anxious to resolve the problem as quickly as possible. So when interviewing the user, guide the conversation and use effective questioning techniques to quickly ascertain the problem. So for instance, use open question. Okay? Like requires detailed response. And closed questions, okay, yes or no, or single word answers to discover important facts about the network problem. All right? So the table here provides some questioning or guidelines and sample open-ended questions you could ask the user. Okay? So something like, what does the network or what does not work? Okay? Or what exactly is the problem? Or what are you trying to accomplish? Okay, so that is asking pertinent questions. Okay, so determine the scope of the problem. Who does this issue affect? Okay, or is it just you or others? What device is this happening on? Okay, so you could ask this question. So these are guided questions that you could ask on your end users. Okay, so when done with interviewing the users, repeat your understanding of the problem to the user to ensure that you both agree on the problem being reported. Okay, so you have to make it clarified. Okay, you clarify your understanding on the problem on the end users. All right. Okay, so gathering the symptoms or gathering information. Okay, So to gather symptoms from suspected networking device, use Cisco iOS commands and other tools such as packet captures and device logs. So the table describes most common Cisco iOS commands used to gather symptoms on a network problem. All right. So although the debug command is an important tool for gathering symptoms, it generates large amounts of console message, or console traffic, and the performance of the network device can be noticeably affected. So if the debug must be performed during the normal working hours, warn the network users that a troubleshooting effort is underway and that network performance may be affected. So remember to disable the debugging when you're done. Okay, so because it consumes a lot of resources. Okay, so this commands that you can use, well, I always use ping, traceroute, and telnet, or even SSH. And the show IP interface brief is a very useful command to display the status of all the interfaces. All right. So you could also use the show IP route. Okay, so to verify that the routing protocols is working via referring to the routing tables. All right. Okay. So let's talk about troubleshooting with layered models. So during your Cisco days, or your Cisco one, right? So you were introduced with the 7 layers of the OSI model, and one of the purpose of having this is this aids the end user, or this aids the administrator in doing the troubleshooting. Okay, so the OSI and TCP/IP models can be applied to isolate network problems when troubleshooting. So for example, if the symptoms suggest a physical connection problem, the network technician can focus on troubleshooting the circuit that operates at the physical layer. So the figure shows some common devices at the OSI layers that must be examined during the troubleshooting process for that device. Okay, so typically, if the problem is on the computer or end systems, so we have to focus on the application, presentation, and session, right? So as network technician, you should have identified all the devices working on the network. So if we're talking about routers or multi-layer switch, so the concentration is on the transport and network layer. So if we're talking about the standard switch or layer 2 switch, it's on the data link layer. If our issue is on the hub, okay, so then it's on the physical layer. If the issue is on the transmission media, it's on the physical layer. Okay. So notice that routers and multi-layer switches are shown at layer 4, the transport layer. Although routers and multi-layer switches usually make forwarding decisions at layer 3, ACLs on these devices can be used to make filtering decisions using layer 4 information. Right? So that's why these two here are within the network and transport layer. All right. Next, structured troubleshooting methods. So there are several structured troubleshooting approaches that can be used. Which one to use will depend on the situation. So each approach has its own advantages and disadvantages. Okay. So this topic describes methods and provides guidelines for choosing the best method for a specific solution. Okay. So these troubleshooting approaches could be a bottom-up, top-down, divide and conquer, follow the path, substitution, comparison, and educated guess. Okay? So, bottom up, good approach to use when the problem is suspected to be a physical one. And then top down, use this approach for simpler problems, or when you think the problem is with a piece of software. Okay? So, divide and conquer, start at a middle layer, example layer 3, and test in both directions from that layer up and down. Okay, use to discover the actual traffic or traffic path from source to destination to reduce the scope of troubleshooting. For substitution, you physically swap a suspected problematic device with a known working one, right? And comparison, it's something like attempts to resolve the problem by comparing a non-operational element with a working one. Okay, and educated guess, success of this method varies based on the troubleshooting experience and ability. Now let's get into each of these troubleshooting approaches. Okay, so let's start with the bottom up. Okay, so in bottom up troubleshooting, you start with the physical components on the network, okay, and move up through the layers of the OSI model until the cause of the problem is identified. Okay, that's why it was named bottom up. You start in the physical, going up to the application layer. So bottom up troubleshooting is a good approach to use when the problem is suspected to be a physical one. So most networking problems reside at the lower levels. So implementing the bottom up approach is often effective. So the disadvantage with the bottom up troubleshooting approach is it requires that you check every device and interface on the network until the possible cause of the problem is found. The disadvantage with the bottom-up troubleshooting approach is it requires that you check every device and interface on the network until the possible cause of the problem is found. Remember that each conclusion and possibility must be documented so that there can be a lot of paperwork associated with this approach. Okay, so a further challenge is to determine which devices to start examining first. All right. So next is a top-down approach. Okay, so this is the opposite of a bottom-up approach. So in the figure, top-down troubleshooting starts with the end user's applications and moves down through the layers of the OSI model until the cause of the problem have been identified. So for each application on an end systems are tested before tackling the more specific network pieces. So use this approach for simpler problems or when you think the problem is with a piece of software. Okay, so the disadvantage with the top-down is it requires checking every network application until the possible cause of the problem is found. So each conclusion and possibility must be documented. So the challenge is to determine which application to start examining first. All right. So next is divide and conquer. Okay. So the figure shows the divide and conquer approach to troubleshooting a network problem. So the network administrator selects a layer and tests in both directions from that layer. For instance, you've started with network layer. So you have to test the network layer, then transport layer, and then from the network layer down to the data link layer. Okay. So in divide and conquer troubleshooting, you need to start by collecting user experiences of the problem. Okay. So document the symptoms and then, using that information, make an informed guess to which OSI layer to start your investigation. So when a layer is verified to be functioning properly, you can assume that the layers below of it are functioning. So the administrator can work up to the OSI layers. So if the OSI layer is not functioning properly, the administrator can work down the OSI layer model. So for example, if users cannot access a web server but can ping the server, then the problem is above layer 3. Okay? If pinging the server is unsuccessful, then the problem is likely at a lower OSI layers. All right? That's how divide and conquer worked. Okay, so next is follow the path. So use to discover the actual traffic path from source to destination to reduce the scope of troubleshooting. So this is one of the basic troubleshooting techniques. The approach first discovers the actual traffic path all the way from the source to destination. Okay? The scope of troubleshooting is reduced to just the links and devices that are in the forwarding path. So the objective is to eliminate the links and devices that are relevant or that are irrelevant to network troubleshooting tasks. So this approach usually complements one or other approaches. Okay? So the next one is substitution. So this approach is also called swap the component because you physically swap the problematic device with a known working one. Okay? So if the problem is fixed, then the problem is with the removed device. If the problem remains, then the cause may be elsewhere. Okay? So in specific situations, this can be an ideal method for quick problem resolution, such as with critical single point of failure. For example, a border router goes down. It may be more beneficial to simply replace the device and restore service rather than to troubleshoot the issue. So if the problem lies within the multiple devices, it may not be possible to correctly isolate the problem. Okay? Next is comparison or spot the difference. Okay? So this approach is also called the spot the differences approach and attempts to resolve the problem by changing the non-operational elements to be consistent with the working ones. So you compare configurations, software versions, hardware, and other device properties, links, or process between working and non-working situations and spot the significant differences between them. The weakness of this method is that it might lead to a working solution without clearly revealing the root cause of the problem. Okay? Next, the last one would be an educated guess. This approach is also called a shoot from the hip troubleshooting approach. This is less structured troubleshooting method that uses an educated guess based on the symptoms of the problem. So success of this method varies based on troubleshooting experience and ability. So seasoned technicians are more successful because they can rely on their extensive knowledge and experience to decisively isolate and solve network issues. So with less experienced network administrator, this troubleshooting method may be more like a random troubleshooting. Okay? Next, guidelines for selecting a troubleshooting method. So to quickly resolve network problems, take the time to select the most effective network troubleshooting method. Okay, so the figure here illustrates which methods can be used when a certain type of problem is discovered. So for instance, software problems are often solved using a top-down approach, while hardware-based problems are often solved using a bottom-up approach. So new problems may be solved by an experienced technician using a divide and conquer method. Otherwise, the bottom-up approach may be used. Troubleshooting is a skill that is developed by doing it. So every network problem you identify and solve gets added to your skill set. Okay, so let's talk about the troubleshooting process now. So troubleshooting software or software troubleshooting tools. So as you know, networks are made up of software and hardware. So therefore, both software and hardware have their respective tools for troubleshooting. So this topic discusses the troubleshooting tools available for both. So a wide variety of software and hardware tools are available to make troubleshooting easier. These tools may be used to gather and analyze symptoms of network problems. They often provide networking solutions or networking monitoring and reporting functions that can be used to establish the network baseline. Okay? So you've got the network management system tools. NMS or network management system tools include device level monitoring, configuration, and fault management tools. These tools can be used to investigate and correct network problems. Network monitoring software graphically displays a physical view of network devices, allowing network managers to monitor remote devices continuously and automatically. Device management software provides dynamic device status, statistics, and configuration information for key network devices. Okay? So the next one is knowledge bases. So online network device vendor knowledge bases have become indispensable, okay, sources of information. So when vendor-based knowledge bases are combined with internet search engines, a network administrator has access to a vast pool of experience-based information. For example, Cisco Tools and Resources page can be found at http://www.cisco.com under the support menu. So this page provides tools that can be used for Cisco hardware and software. So the third one is baselining tools. So many tools for automating the network documentation and baselining process are available. Baselining tools help with common documentation tasks. For example, they can draw network diagrams, help keep network software and hardware documentation up to date, and help to cost effectively measure baseline network bandwidth use. Okay? Okay, so next is protocol analyzers. Okay, so the protocol analyzers can investigate packet content while flowing through the network. A protocol analyzer decodes the various protocol layers in a recorded frame and presents this information in a relatively easy to use format. So the figure here on the screen, okay, shows a screen capture of the Wireshark protocol analyzer. The information displayed by a protocol analyzer includes the physical layer bit data, data link layer information, protocols, and descriptions for each frame. Most protocol analyzers can filter traffic that meets certain criteria so that all traffic to and from a device can be captured. Protocol analyzers such as Wireshark can help troubleshoot network performance problems. It is important to have both a good understanding of TCP/IP and how to use a protocol analyzers to inspect information at each TCP/IP layer. Okay, so next is the hardware troubleshooting tools. Okay, so there are multiple types of hardware troubleshooting tools. This includes digital multimeters, cable testers, cable analyzers, protocol network analyzers, and the Cisco Prime NUM. Let's go over each of these components or tools. Okay, so the first one is a digital multimeters or DMMs, such as Fluke 179 shown in the figure, are test instruments that are used to directly measure electrical values of voltage, current, and resistance. So in network troubleshooting, most tests that would need a multimeter involve checking power supply, voltage levels, and verifying the network devices and receiving power. So next is cable testers. So cable testers are specialized handheld device designed for testing various types of data communication cabling. So the figure here displays the Fluke Link Runner 18 network auto tester. Cable testers can be used to detect broken wires, crossed over wiring, shorted connections, and improperly paired connections. These devices can be inexpensive continuity testers. So moderately priced data cabling testers or expensive time-domain reflectometers or TDRs. So TDRs are used to pinpoint the distance to break in a cable. These devices send signals along the cable and wait for them to be reflected. So the time between sending the signal and receiving it back is converted into distance measurement. So the TDR function is normally packaged with data cabling testers. TDRs used to test fiber optic cables are known as the optical time domain reflectometers or the OTDR. So the third hardware tool is the cable analyzers. So cable analyzers such as Fluke DTX cable analyzers in the figure here, okay? These are multifunctional, multi-head or handheld devices that use to test and certify copper and fiber cables for different services and standards. The more sophisticated tools include advanced troubleshooting diagnostics that measure the distance to a performance defect such as near-end crosstalks or NEXT, or return loss or RL. So identify corrective actions and graphically display crosstalk and impedance behavior. Cable analyzers also typically include PC-based software. So after field data is collected, the data from the handheld device can be uploaded so that the network administrator can help create an up-to-date reports. Okay, so next is protocol network analyzers. So portable devices like Fluke OptiView, okay, shown here in the diagram, are used for troubleshooting switch network and VLANs. By plugging in the network analyzers in anywhere on the network, a network engineer can see switch ports to which the device is connected, the average peak, okay, or the average and peak utilization. So the analyzer can also be used to discover VLAN configuration, identify top network talkers, hosting generating the most traffic, analyze network traffic, and view interface details. The device can typically output a PC or to a PC that has a network monitoring software installed for further analysis and troubleshooting. So the last one is the Cisco Prime NUM. Okay, the Cisco Prime NUM, or the Network Analysis Module portfolio as shown in the diagram, includes hardware and software for performance analysis in switching and routing environments. It includes an embedded browser-based interface that generates reports on the traffic that consumes critical network resources. In addition, the NAM can capture and decode packets and track response times to pinpoint an application problem to a network or server. Thank you for watching and listening. Have a great day.